Hello students, welcome to Simplified Physics and Maths. Today I want us to look at moment or torque. Moment or torque. Now I know you know a spanner. It's an instrument that we use to tighten or loosen bolts. Now if you have a spanner and maybe you want to use it to tighten or loosen your bolt, you hold one end and you apply a force. Either you push it or you pull it. Now when you pull your spanner, what happens? You see that the bolt will rotate at the other end. So by pulling the spanner, it causes the bolt to rotate at the other end. You apply a certain force and that force causes a rotation at another end. So the tendency of a force to cause an object to rotate is what we call moment or torque. Moment or torque. Actually, the engineers like saying moment and the physicists, they like saying torque. They are the same, so I will be using them interchangeably. Whenever you apply a force to an object, and that force is able to cause the object to rotate, then we call that idea or the whole as moment or torque. So let's say this is my spanner. This is where the rotation occurs, and this is where I apply my force. Now, the point where the rotation occurs, we call it the axis of rotation. The axis of rotation. So this is the applied force. The applied force. So what are we saying? When you apply a force to an object, and that force causes the object to rotate, or when you apply a force to an object and it's able to cause the object to rotate, then that idea is moment or torque. So you realize that there is a distance between the axis of rotation and then where I applied my force. We call this distance perpendicular distance. Perpendicular distance. Why are we calling it perpendicular distance? Because it makes an angle of 90 degrees with the force. It makes an angle of 90 degrees with the force. So the moment of a force or torque is given by, the symbol is this, the force which you apply multiplied by the perpendicular distance. Remember, D is the perpendicular distance. D is the perpendicular distance, not any distance at all. So from this, we can say, if you want to find the units for torque, the unit for force is Newton, the unit for distance is meters. So we have Newton meters. So the unit for torque is Newton meters. Newton meters. Let's look at this particular example. So let's say you have a spanner as an example. I have my axis of rotation here, let me call it A. I apply a force of, let's say, 20 Newton at one end. And the distance between the axis of rotation and where you apply the force is, let's say, 6 meters. And I want to find the moment about the point A. How do I go by it? We know moment is given by force times perpendicular displacement. So moment is equal to, my force is 20, my perpendicular displacement or distance is 6. So torque will be 6 times 2, that will be 18, sorry, 12, so 120 Newton meters. And it's as simple as that. It's as simple as that. Let's take another example. Let's say this time around, you have your force being applied here. The axis of rotation is here. And the whole of this is, let's say, 5 meters. And from this end to this end is, let's say, 2 meters. And the force that you apply is, let's say, 6 Newton. And you have been asked to calculate the moment about the point A. How do you do it? You know, moment is force times the perpendicular displacement. So moment is equals to my force is 6. Now what is my perpendicular displacement? It's not 5. Because how do you calculate for the perpendicular displacement? Where you apply the force to the axis of rotation. You must know that. Understand that the perpendicular displacement is calculated or determined by measuring the length between where the force is applied to the axis of rotation. So the length from where I apply my force to the axis of rotation will be, if the whole of this is 5 and from here to here is 2, then here will be 3 meters. So 6 times 3, and that will give me 18 Newton meters. 18 Newton meters. Let's take this one too. Let's take this example too. This time around, you have your bar like this, and the force is here. 5 Newton. The angle here is 30 degrees. That will be like 2 meters. And you are asked to find the torque about A, or the moment about A. Now, I know someone will quickly say, oh, moment equals to force times displacement, so 5 times 2. And the person will get 10 Newton meters. This is wrong. The reason why it is wrong is that this distance is not perpendicular distance. It is not perpendicular distance because it doesn't make an angle of 90 degrees with the force. Remember, perpendicular distance means that that distance makes an angle of 90 degrees with the force. But the angle here is 30. So it means you cannot use this distance because this D means perpendicular distance. But the distance is not perpendicular. So what do? You just have to determine your own perpendicular distance by drawing a line. You can draw a line from the axis of rotation to where you apply your force. And then this will become your perpendicular distance. And using the idea of SOHCAHTOA, you can find the value of D. So from this opposite hypotenuse, so sin 30 degrees equals to opposite over hypotenuse. So D is 2 sin 30 degrees. So sin 30 is 0.5. So we get 1 meter. So it means the perpendicular distance is 1 meter, not 2 meters. And so my torque becomes force times perpendicular displacement, which is force is 5. The perpendicular displacement is 1. So I get 5 Newton meters. 5 Newton meters. Today we have been able to define torque. We said that torque is the tendency of a force to cause an object to rotate. And it is given by force times perpendicular distance. Remember, we determine the perpendicular distance by measuring from where the force is applied to the axis of what? Rotation. So let me ask you a question. If we apply the force on the axis of rotation, what do you think will be the torque? And let me ask you another question. You have two spanners. A longer one, let's say one is about 10 meters, and another one is about, let's say, 5 meters. And then you apply the same amount of force at the end of each spanner to open maybe a bolt or to tighten your bolt. Which spanner do you think will help you or will make it easy for you to open the bolt faster? Will it be the longer one or the shorter one? When we meet next time, we shall discuss that question. Thank you for watching. Don't forget to subscribe.